Hey there, we the learners of WebDev-6 are here to walk you through the problem Bella Ciao. Bella Ciao is a CodeChef problem with a difficulty of 1410. This problem relates to the web series Money Heist, that's why the name Bella Ciao. Let's look into the problem. Imagine this, Chef and his team are planning to heist the Reserve Bank of Chefland. So this is not going to be some kind of typical robbery, but they are going to hijack the bank and print money day by day. So initially they are going to print the money at a certain rate, let's say p dollars per day. After a set of days they are going to increase the amount by q dollars per day, that will be p plus q dollars per day. So again, and after another set of days, they are going to print the money at p plus 2q dollars per day. This goes on until the end of the heist. Our mission here is to find out how much money will Chef make at the end of the heist. So guys, are you ready to join Chef on this adventurous heist? Let's get into it.
Now let us understand the problem generally. We already saw the pattern of the problem. So here is a visualized version of it. You can see that P is the initial money and Q is going to be the increased money after every interval. So there will be a pattern like this: P plus Q, P plus 2Q and P plus 3Q. So when we see the first test case, for every test case there will be a single line of input. On the first line we'll have a number of test cases, and for each test case we'll have four inputs, that is capital D, small d, capital P and capital Q. So when we see about the first test case, capital D would be a total number of days and small d would be a change in interval. P is initial money, Q is the increased money after an interval. So in the first test case, they have given capital D as 3. So we are hijacking the bank and printing the money for total number of 3 days. And for every 1 day, we are going to increase the printing of money by $1, which is Q here. On the first day, we will print $1. On the second day, it is P plus Q. That will be 1 plus 1, that is 2. On the third day, we'll print P plus 2Q dollars. So 1 plus 2 into 1, which will give us 3. So now we have to calculate the total money printed. So that will give us 1 plus 2 plus 3, which is $6.
As of now, we understood what the problem is and also know what are the inputs. Now it is time to discuss the approach that we're going to follow to solve this problem. We all know that we need to find the total money that Chef is going to print in capital D days. And we also know that in capital D days, we're going to have number of small d days intervals. Let's first calculate the total number of full small d intervals fit into the total number of capital D days. To do this, we're going to use the integer division. For example, if the chef is printing the money for 10 straight days and the rate changes for every 2 days, we can tell that there are total 5 intervals are there. Now, after calculating how many full intervals we have in the capital D days, there may be still some leftover days that don't fit into a complete interval. To find the number of these leftover days, we use the modulus operation. If we take the capital D days as 11 days and the interval, which is small d, as 2 days, this means there will be one remaining day after all the intervals because 11 modulus 2 is 1. Now we know that number of full intervals and the leftovers. We can calculate the total money printed by Chef in these intervals. Think of this arithmetic progression to find the total dollars printed by Chef for the capital D days, where the rate increases by Q for every interval. First part of this arithmetic progression is used to find the production rate across all intervals. Second part of this, add the extra money printed due to all the increasing rate after each interval. We found out the total dollars Chef printed in full K intervals. Now we have to calculate the money printed in remaining leftover R days so that we can get the total dollars printed. Finally, to get the total money Chef printed, we can simply add the money from the full intervals and the money from the remaining days. By following all these steps, we're going to get the total money printed by the Chef in capital D days.
Let's walk through the flowchart that outlines the solution to the problem. We begin by reading the number of test cases, then we initialize the counter to 0, then we enter to the loop. Inside the loop, we take up 4 parameters where d stand for number of days and the small d stand for number of interval of days, and p stand for amount of money printed per day, and q stand for increment of money after every interval. Once the input are received, we call the function total money printed with the parameters ddpq. Inside the function, we calculate k, which is the number of which is the number of complete intervals, and the R the number of remaining days, and the complete intervals which calculates the money and printed in a full intervals, and the remaining day printing which calculates the money printed for the remaining day after the full intervals. We sum these two values to get the total money and return the result. Then we print the result. These loops continue until the test cases are processed, and then we end the program.
Now let's take a look at the code for this problem. Firstly, we create a T to ask the user how many test cases they want to run. We use a count as a counter which started at 0 to keep track how many test cases we have to run. Then we use the while loop to take a input from the user where while loop is continuously run until the our count reaches to t. There are four input variable is capital D, P and Q, where D stand for the total number of days, small d stand for the interval at which the printing amount increases, P stand for the initial amount of printed each day at the starting, and Q for the additional amount printed each after the interval. And we use the map to store them, and use the split to split the input, and we call the our function total money printed. We pass the all the parameter where k calculate the total interval, and r is the remaining date. Total interval calculated is followed by this formula, and remaining days calculated by this formula. And finally we return the sum of money printed during the complete interval and the remaining day. Now submit the code. It properly works.
Now, let's quickly analyze the time complexity and space complexity of our algorithm. Time complexity is the amount of time an algorithm takes to produce the result, whereas space complexity is the amount of space an algorithm uses from computer's memory to produce the result. Here, in our function, the, each of the statement is made up of basic arithmetic operations such as addition, subtraction, multiplication, division. Each of these arithmetic operations take constant amount of time to execute the result. So we say that our function is taking constant time, that is big of one time to produce the result. Similar to that, the space complexity is also big of 1 because it is only taking 4 integer inputs. These are said to occupy only unit amount of space in the computer's memory. There are no additional data structures such as lists or queues that are being used here. So we can say that the space complexity is also big of 1. And there are t test cases in our problem. Therefore, we can conclude that our overall program is taking big of t time and big of t space.
Throughout our analysis, we established a systematic approach. We began by identifying the number of complete intervals within the total days, allowing us to calculate the printed amounts efficiently. We then applied a clear formula to compute the earnings for each interval, considering how the production rate escalates over time. Finally, we accounted for any remaining days after the full intervals, ensuring that every day of printing was included in our total. This problem not only highlights fundamental mathematical principles but also showcases the importance of strategic planning and resource management. In real world scenarios, such strategies can be crucial for maximizing output and efficiency, whether in business, finance, or operation. With this, we come to close our discussion. Thank you.